Hey guys, all right, let's try this again. We're going to be doing our last genetics unit. Luckily, I got my paper cut dealt with. So I've got a nice pressure here. Should be good to go for this video. Our final topic that we're going to be talking about for genetics is blood types. So as you can see behind me, I've got a board. I've got some information here. I'm going to go through it. This video will be a little bit longer than some of the others, but bear with me. All right, so blood types. So the interesting thing about blood types, and the reason why we've left this till the very end of the genetics unit, is because blood types are determined by multiple alleles and are incompletely dominant. So you've probably heard about blood types before, right? So multiple alleles, incompletely dominant. There are 4 blood types. You can either be blood type A, B, AB, or O. Those are the 4 blood types. You can also then be positive or negative, but we're going to be talking about that in a second. All right? Blood types are determined by the presence of specific proteins on your red blood cells. And there are 2 proteins. There's an A protein and there's a B protein. All right? So basically, you can have just A proteins. You can have just B proteins, you can have both A and B proteins, or you can have no proteins. And those are how the 4 blood types are determined. If you have just A, you have A blood. If you have just B, you have B blood. If you have both A and B, you have AB blood. If you have no proteins on your red blood cells, you have O blood. And the presence of those proteins are determined by your genes, all right? Just like all the other traits we've been talking about, one copy of a chromosome could say have A proteins. One copy could say have no proteins. And that would give you a genotype of A. And then we call the other one lowercase I. So if you look over here, I'm going to move this a little bit so you can see that a little bit closer. Okay. Here are all the possible genotypes. You could have 2 copies of the A. That would mean you have A blood. You could have 1 copy of the A and then 1 copy that says no proteins. But because this is incompletely dominant and multiple alleles, that A would overpower this lowercase I, meaning you would have A blood. It would still say, yes, you'd have that protein. But you'd be a carrier for this blood type with no proteins. Same with B. You could have 2 copies of the B or 1 copy of the B, 1 copy of nothing. Both of those would be B blood. Or both your chromosomes, both copies of your chromosomes, could both say 1 have A, 1 have B, which would result in AB blood. That's the rarest of all the blood types. I think only about 4% of the world's population is AB. I'd have to look that up more specifically. And then finally, you could have little case I, which means that your both copies of your chromosomes are saying that you're going to have no proteins, and this would result in O blood, okay? Now, the reason blood types are important, in your day-to-day life, they don't really matter. There's no benefit to having A, B, AB, or O blood per se. It becomes very important, however, if you ever need a blood transfusion. If you have lost a tremendous amount of blood, then you would go to the hospital and they would need to put blood into you to make you better. And in that case, they'd want to make sure they put the same type of blood in you. If I am A blood, I can't have B blood of any type put into me, meaning I couldn't have B blood or AB blood. The reason for that is your blood types with those proteins are recognized by your body. And if you have blood cells that come into your body that have a different protein type in them, your body recognizes that blood as foreign and attacks it. And that leads to massive clotting, which kills you. So you have to have your own blood type put into your body. And if you have someone else's blood type, it makes you really sick and die. And they discovered this during the Civil War. Surgeons at the time would literally hook up tubes from one person to another and be like, oh, this guy lost a lot of blood. Let's give him some of Johnny's over there. And sometimes this had great success, and sometimes the person died horrifically. And that was how we began to realize that we all have different blood types. So you might have seen this before. AB blood type is usually referred to as the universal receiver. That's because AB blood can take donations from A, B, AB, or O blood. O is considered the universal donor. Because O blood has no proteins on it, any blood type can receive it in a transfusion, because with no proteins on it, there's nothing for the body to recognize as being bad. So O blood is called the universal donor because it can donate to someone with A blood, B blood, AB blood, or O blood. However, O blood can only receive blood from an O donor. Okay, so if you are ever O blood, it's really important if you get a chance to give blood. All right. So what if we did a cross? The interesting thing, and I'm not going to ask you guys to do many crosses of this. There's going to be one last problem set, which will involve some of this. But let's say you had someone who was A blood, but was a carrier for O, and someone who was B blood, but was a carrier for O. If you did this cross with our Punnett square here, you could see that this cross of these two people, one with A blood, one with B blood, could result, there's a 25% chance they'd have an offspring that had AB blood. There's a 25% chance they'd have an offspring that had B blood. There's a 25% chance they'd have an offspring with A blood. And there's a 25% chance they'd have an offspring with O blood. So this gets very confusing very fast because of those multiple alleles and the fact that they can both be expressed blended together in that AB form. All right, final thing, the Rh protein. Rh refers to the rhesus monkey. You might have heard of those. That's where this protein was originally discovered. And the Rh protein is what determines whether blood is positive or negative. And this is less important than blood type when giving a transfusion. But basically, it's simple, dominant, or recessive. If you have the gene, your blood is considered positive. It's another protein found on your red blood cells. If you don't have the gene, it's recessive. That means you have two copies of the recessive. That means you are negative. So if I was A positive blood, I would have A proteins and the Rh proteins. All right. The reason Rh is less important is during a transfusion, the Rh protein is only triggered once. So this is really important with pregnant women. Meaning if I was negative and I received positive blood into my body that time wouldn't trigger a reaction. I'd be fine. If I got positive blood in me again, then I'd have the antibodies in my blood and then I would get really sick. All right. But generally doctors don't worry about this the same way as they do blood type. It's more important to know whether you're getting A, B, AB, or O blood. All right. This is very confusing. Thank you for bearing with me. Go ahead and check out the other documents that I'm going to post on Google Classroom for more information, and let me know if you have any questions. Take care, guys.